All right, as people are moving on to the peer review, I've got my solution to the homework here. So the homework was to write a decorator that made the slow Fibonacci function fast. So here was my first implementation. The decorator was called make fast, and it's just a function that takes in a function. And then the first thing I do is I make a cache, some memory to hold values in. And then I find my wrapper, and I check if we're trying to call func on some end that's in the memory already. And if we remember the old solution to fib of n, then we can return that. Otherwise, we call func and then return the result. So this is just a simple cache where the wrapper takes an n. Wrapper takes an n because func takes an n. And then we use this mem dictionary as a cache for func, which we're now wrapping in wrapper. So that's kind of the straightforward implementation. That's the way I kind of expected people to do it. There's different ways to do it too, so if this isn't exactly what we did, that's totally fine. Some people use an array instead of a dictionary. But like last week's homework, there was an easier way. Last week we did the specializer function, and it turns out that was built into Python, and it was called partial. Well, it turns out this is also built into Python. So, did I get you again? Yeah. So, you can use LRU cache as a decorator like this. You say at LRU cache, you pass in the size, and then you define a function, and that function will then be cached in a dictionary-like object. And so this is the alternate implementation. Can anybody explain why we have to call LRU cache on none here? Don't have a size. Yeah, we have to supply a size. But make fast is supposed to be a decorator, right? So why are we calling the decorator? Because yeah. So the way that we did decorators that take in arguments is we wrote a function that returns the decorator. And so that's what we're really doing here when we use the decorator like this. Is LRU cache is a function that returns the decorator. So to make fast like this, we have to call LRU cache, and then this is going to return the decorator. So just a throwback to last week. So, who's still working on the peer review? Who's still working on the feedback form? Okay, any questions about this?
So, if you pass in none as the size?
It's unbounded.
Okay, so that's just because they limited that.
Yeah. Other questions about this? Was there a question over here?
No, I was just saying I didn't finish them.
Oh, okay. Other questions about this? So, turns out the partial function from last week that was built into Python that solved the homework was also in this module called functools. So I highly recommend that you guys check out functools. There's some really cool stuff in functools, including LRU cache. So. One interesting thing here is that this makefast decorator, the wrapper takes an n. This is actually making the assumption that func also takes an n, because whatever the wrapper takes in, the wrapper should take in the same things that func takes in. So this makefast implementation only works on functions that take in one thing. LRU cache, the built-in decorator, works on any functions. It will cache whatever you pass in. So this is a slightly more general implementation. It will work on fib or whatever. Okay, I'm going to move on because today is probably the most confusing lecture of the whole metaprogramming curriculum. So if you're not done with your peer eval or the feedback form, I would just go ahead and close your computer because this is so confusing. It's like if you blink, you'll miss it. It's mind blowing. I hope everybody's mind will be blown today. But to get to the mind blowing part, I want to review do, init, and call. These were 3 dunder methods that we've been implementing throughout the class so far. Init is the constructor, basically, and it takes in the instance self, and then you populate self with a bunch of fields. New is a method that gets called before init, and it returns self. So, you might ask, where did init get this self from? Who made self? Well, new makes self. So new is a class method. It takes in the class itself, and it makes the instance and returns it. And then that instance gets passed into init, and init populates that instance. And then call is kind of separate because call is optional. Call is not part of the process of creating an instance. Call is what we implement if we want to make our instance callable. So if we want our instance to be usable as a function, we implement call. So just a quick review here. I'm going over this because these are the 2 functions that are going to be interesting to look at when we end up getting to where we need to go. So quick review of new, init, and call. Any questions about this? Attendance sheet. Who has not signed the attendance sheet? 1 person. Okay. All right, awesome. Okay. So I want to talk about this function called the type function. We've been using it throughout the lectures. Let's say we have this class here. It's your generic person class. Takes in a name and an age. Has a talk method. If we make a person instance, we can call type on that instance, and we get the type of the instance, right? So what do we expect here? Person, yeah. A is an instance of person. That's how we're used to seeing this function be used. We're used to seeing it as an inspector, a way to inspect the class of some object. But it turns out there's another way to use the type function, and it's for class creation. So instead of inspecting the type of something, we can create a type. And the way we do that is a little weird. First of all, I'm going to define the same functions that we defined inside the class outside. Just going to define them outside. And one weird thing here is that this function here, it's not part of a class. So it's not clear what we're initting. If we take in self here, but it's not clear what self is, this method is not a method, this is just a function. So we just so happen to call this first variable self. But it's just a function. And it just happens to be exactly the same as this function. And we're going to define talk the same way. And now here's the magic. We can call this type function, but instead of passing in 1 argument, we're going to pass in 3 arguments. And those 3 arguments are the name of the class that we want to make, the base classes, and then a dictionary. And so if we do that, we can construct an instance of this type, alt person. And that instance behaves just like the instance that we constructed over on the left. And if we get the type of B, what do we expect?
The init is wrong. So
The init is wrong?
isn't it just a name? We tested a name and a page.
Oh, yeah, that's a typo.
Aside from that,
That was a typo in last time I taught this, and I forgot to fix it. Yeah, imagine that was...
aside from that, it'll be a fault.
So what do we expect here? Alt person? Yeah, because alt person is a class now. Alt person is a class. We created an instance of that class called B. We're getting the type of it. The type was alt person. The only difference here is that instead of writing this class like we're used to seeing it, like with the class syntax, we've written it with a function called a type. And we've passed in the context, the contents of the class as parameters. And you can kind of see a mapping here, like, alt person is this part, and the bases are what come after it. And this dictionary is kind of like the body of the class, mapping the names of these functions to the functions themselves. Questions about this slide?
How did all person know that how to do the talk method?
Alt person knew to do the talk method because we passed it in here. So I guess I didn't say explicitly what these parameters are. This is the name of the class. These are the base classes. And then this is everything that we would have written in the class. So if we mapped like, let's see, if we had mapped, instead of saying talk here, if we had said speak, and then mapped it to the function talk, then B wouldn't have a talk method, it would have a speak method.
What is dunder main?
Dunder main?
Yeah, is there a main?
Oh, good question. That's the module we're in.
Okay.
And so when you're in the, if you're in the module that the Python interpreter executed first, then module is always called main no matter what it actually is. So because we're in the shell, it's the first module that got interpreted, so it's main.
If you then import classes from other modules, would appropriate the same.
Yeah, so like let's say we imported a class from some other library and we created an instance of it and then we called type of that instance. Instead of saying main here, we'd probably say library dot or whatever the library's called. Yeah. Other questions about this?
So when you call type of A, is it generating a new object or is it returning something?
Good question. It's returning something that already exists. Yeah. How about this? All right, I've got a question. What if we hadn't put alt person here? Right? It kind of was convenient that this matched that, right? Like we created a class, and the first thing we had to pass in was the name of that class. And then we just have to set that class variable to a variable that was called the same thing. But what if those didn't match? What if this just said person? Or what if this was just called capital P person or something? What would happen?
Maybe the constructor would be alt person and the class name is whatever your class name is.
Class name. So the constructor would be alt person. So you're saying if we changed this,
Yeah,
but we left this?
yeah.
Yeah. So turns out there's two different things going on in Python that you don't usually think about. There's the thing itself and what Python refers to it as. So here, this class that we created on the left, the person class, we're calling it person. Like we're referring to it through a variable, a name, person. But it also just so happens that because we used this class syntax, the name of the class is also person. But they don't have to agree. We could have said, there's no chocolate here. We could have inserted a line right here where we say capital P equals person. And then just like how we constructed an instance of person, we could construct an instance of P because they're the same thing. So we could have said A equals P. But then if we had said A equals P, what would we have gotten when we had said type of A? Person still, yeah. So there's the name of the class and then the name of the variable we refer to the class through. And here, because we use the convenient class syntax, the name of the class and the name of the class variable are the same. But here you can see a little bit more explicitly what's going on. The class has a name, and then there's a variable we refer to it through, and they don't have to match. So this seems kind of useless here, right? Like, why would anybody write a class like this? This is just so unreadable. It's much better to do this in most instances. But the cool thing here is that because we've turned class creation into a function call, we can do it dynamically. So here's an example of a case where it might be useful to use the type function. We've got a person class again, and it takes in a first and last name, and then it sets the name variable to the first and last name concatenated. We've got a talk method. And now we're going to find a class method. By using the class method decorator here, the first parameter that gets passed into the method is going to be the class itself, instead of an instance of the class. So we have a reference to the class itself. What is this going to be? most likely.
Person.
Yeah, capital P person. This is going to be the class as a variable. I'm going to take a family name, and here's what we're going to do. We're going to define an inner function called init that takes in the same things as that init did, but we're going to make it so that the last name has a default argument, the family name. And then we're going to call the superclasses init. Alright? And then we're going to return a new type where the name of that class is the last name. It inherits from class, and it has a new init function. Alright? So what is this useful for? Well, let's say we have a person, Steve. Steve is Steve Jobs. If we say Steve.talk, we get I'm Steve Jobs. What if we say person.makeFamily Paddock? What is this going to return? What is this function call return?
New class.
A new class, yeah. We've called this function and it returned us a new class. And this new class, through which we're referring to by a variable called fam, the new class, the actual class name is Paddock, and it inherits from person with this new init method. So let's see what happens. If we construct a fam whose first name is Max, we didn't have to pass in a last name here because the init function for this new subclass has a default parameter, the family name. So now if I construct a Max, the default is Paddock. So now if I talk, Paddock got there. Because we created this new class that has Paddock as a default. Now the cool thing is if we say the type of Steve, we get a person. But if we get the type of me, I'm a Paddock. And you can check if I'm an instance of a person, what do we expect here? True. Because this new type inherits from class. So class was capital P person. So Paddock inherits from person. So I'm a Paddock, so therefore I'm also a person. Is Steve an instance of fam? No, Steve is not fam. Questions about this?
I have two. First, what if you said like Max Jobs at the fam constructor? It still takes fam name as the last name.
Yeah, so you can override this default parameter. So if we had said me equals fam max comma jobs, then I would be max jobs. But my type would still be Paddock. Yeah, good question. Question?
Is Paddock a instance of person?
Paddock is a subclass of person. Because we passed in the class here as a base. Yeah.
Can you like, instead of on type, can you pass none and make a class that doesn't inherit from object?
Good question. I don't know. I don't think so. I think that would fail at runtime because none is not a class. And so I think it would just say no. You could try doing an empty tuple, but then I think that would implicitly inherit from object. Other questions?
What exactly is that class method decorator doing?
It's something that's built into Python. I think you don't even need to import anything. And what it does is it tells the class that when this method is called, instead of passing in an instance, you should pass in the class itself. So that's actually an interesting point here. Here we said person.makeFamily, and we got this new fam subclass Paddock. But what if we had said fam.makeFamily? Then what would CLS be?
It would be Paddock.
It would be Paddock. Because CLS is the class you're in. And so when we create this subclass, the subclass now has a new CLS. And so when this method gets called from fam, CLS will be Paddock. And so if we were to make a family off of Paddock, it would inherit from Paddock, and then Paddock would inherit from person. So it's a way of referring to the class you're in if you don't know what it is ahead of time. So here, this makeFamily class, since it might be called from a subclass, that's why it's convenient to pass in the class itself. is an instance. It's confusing because we're not used to thinking of classes as objects. But just like functions, classes are objects, and so you can pass it in as that first instance, and that's what that decorator does. Other questions about this? Okay. But I've been lying, because type is not a function. Any guesses to what type is? Type is actually a class. So let's see what that means here. If we get the type of 42, we get int, just like we expect, right? If we get the type of int, what is the type of int?
Function.
For a couple things. Yeah, 42 is an int, so the type of 42 is an int. But int is a type. So what is the type of this? It's type. Okay, so what's the type of type? It's type. So the type of an object is its class. The type of a class is type. The type of type is type. So this is kind of a fixed point here. We can do this over and over and over again as much as we want. We're always going to get type out. Is type an instance of type? Who says yes? Who says no? I think it's true. Yeah, it's true. Yeah, type is an instance of type. And we can see that because we inspected the type of this thing and it was type. So type is an instance of type, just like 42 is an instance of it. Alright? What's the MRO of type? Type object? I think that's a pretty good guess. Or maybe you really know. I don't know. Type MRO is type object. Why? Why is that? Yeah, because everything's an object. Right? That was slide set 1. We went through a bunch of stuff, and I got the type of all those things, and I said .MRO on all those things, and every MRO ended with object. So there's no such thing as an MRO that doesn't end in object. So type inherits from object. So is type an instance of object?
Because you're asking that question, no.
Who says yes? Who says no? Who has no idea? It's true. Type is an object. Because everything in Python is an object.
Instance.
Is object an instance of type?
Yes.
So, what is this thing? What is object?
Into the constructor.
Object is a class, isn't it? Isn't it a type? So, doesn't that kind of say itself? Yeah, object is a type. Is object an instance of object?
Yeah. Yes.
Yeah, just like how type is an instance of object. Everything is an object. So, object is an object. Yeah. Is one an instance of object? Yes. Is one an instance of type?
No. Yes. No.
No, what is this thing?
Int.
It's an int.
Instance of the
Can we create instances with it? No. No. This thing, if we were to call it, it would break. This thing is not even callable, much less a class, much less a type. So no. Is this weird or what? Type is an instance of type. Type is an instance of object. Object is an instance of type, and object is an instance of object. It goes all ways. Question?
Yeah, what would be the type of
Type of an object. Like just an object. Like if we were to call object constructor here, and just get an object,
Right.
what
I'm thinking
what
about
is
type
type?
of object. Where it's like you have is instance object type. Like can you call type on just an object? Or is that not a thing?
Can you call type on object? Oh, I see. So you're saying like, let's see. Like that. If you were to call type on object, you would get type. Because object is a class. It's the class that everything inherits from. So it's definitely a class. And classes are types. So it's type. So the type of this is a type. Here's an interesting question. What about this? Now what is it? Object. Yep. Because this is an instance of object, and the type of an instance of object is object. Okay.
A bit off track, but int is also a function, right?
Int?
Yeah,
No.
but it's callable.
It is callable. Aren't classes callable?
Oh, but it works as a constructor.
Yeah. So every time you've called the int function to cast something as an int, you've really been calling the int constructor. And each time you've actually called type on something to get the type of it, you've actually been calling the type constructor. But there's a special form of the type constructor that where if you pass only one thing in, it'll inspect the type instead of making a new one for you.
So constructors are not functions?
Constructors, there are no constructors in Python. There's initializers, there's new, and there's call methods. And they work together to create objects. But they're really just functions. They're just functions.
So everything actually is a function, but sometimes it's a constructor that looks like a function.
I would say that's a pretty good way of putting it, yeah.
Sorry for asking, but like we couldn't do is A inherits from B, B inherits from A. It's like too ambiguous. Why doesn't that happen here?
This isn't an inheritance. That's a great question. What's objects MRO? What's objects MRO? Just object. So it's not two-way inheritance. Object doesn't inherit from type. But object as a variable is an instance of type. So we've gone into another plane here. We're used to classes being kind of vertical, and we see this tree in front of us of the class inheritance structure. But on top of that, in addition to there being a class inheritance structure, there's a metaclass dimension. Each class also has a class of itself. The classes are objects, right? We've been saying functions are objects. We've also been saying classes are objects. But all objects must have a type. And so if classes are objects and objects have type, then classes have type. But the type of a class is its metaclass. Because we have to differentiate between the class and the class of the class. The class of the class is the metaclass.
Which is just a constructor's class.
Yeah, you could think of it that way. Yeah. Okay? Everybody's mind sufficiently blown? Melted down? Okay. So what the heck is this useful for? Well, if type is a class, can't we subclass it? Well, yeah, we totally can, and that's how we make custom metaclasses. So we're going to make a metaclass here, and you'll see how this is useful. First off, though, we should see just exactly what happens when we define methods in the metaclass. Like, what does it even mean to define a custom metaclass and override the methods? What does that do? So we're going to make a metaclass here, and we're just going to define new and print out that we're calling new. Define init, print out that we're calling init. Define call, print out that we're calling call. So we're just going to see exactly what's going on here. This is a class that inherits from type. So its instances are what? What are the instances of this class?
Constructors?
Classes. The instances of this class are classes. Okay? And now, just so that we have something to build off of, I'm going to define an init and a talk, just like before. That way we have something to build off of. We're going to put those in a dictionary too. So, okay, if metaclass inherited from type, then we should be able to use metaclass just like how we used type. So just like before, we're going to call metaclass. Metaclass now inherits from type. And we're going to pass in the three things: the name of the class, the bases, and the attributes. The attributes was the dictionary we defined earlier. And right away, we get new is called. And then we get init is called. This makes sense, right? Because in a lot of ways, this is just a regular class. This is just a normal class. And creating instances of it calls the new function first and then calls the init function. So this is just like any other object instantiation so far. We've just created an instance of metaclass, and new and init got called. Now it just so happens that that instance that we just created is now a class. And so we can instantiate it. Now instantiating the instance of our metaclass does what? What is MP now? What is its type? Metaperson. Yep, because metaperson is a class. And what are we doing here with that? With this object? This is a class. What are we doing with it? We're calling it. So what do we expect to see? The call method. And now MP is just any old person object. This is kind of weird, right? Because we defined this call method in the class's class. And yet, it's the call method that was run when we created an instance of the instance. So despite this metaclass being kind of like a level removed from actual objects and actual instances, this call method is, we get a hook into regular object instantiation. It turns out we're used to seeing this, like this is a class, and we're calling the class, so we're used to new and init being called, just like here. Whenever we call a class, we get new and init. But here we call the class, and we got call. The metaclass is call. Turns out, if we had also debugged, I'm hitting the wrong button. If we had also, in this init, if we had printed out that we're calling that init, maybe if we had defined new as well, then down here we would have seen call, and then new, and then init. So it turns out I was kind of lying. I said that the order of calls goes new and init. That's not technically true. The first thing that gets called is the metaclass's call. So the metaclass's call gets called, and then that call usually will in turn call the class's new. And then that will return an instance of self, and then the call will call init on that self. But you can see the call method of the metaclass is really what drives the entire process. This is what gets called first. The new and init protocol is actually implemented by type.underCall. Because calling an instance of type is constructing an object. Does that make sense? Okay, so this wasn't a very useful example, but it's simple, and we can use it to illustrate some nicer syntax. Here we had to do this weird thing again, where we call the metaclass and pass in the things, kind of ugly. Turns out there's a better syntax. We can create the class, and then pass in the metaclass as a keyword arg, as a superclass. And so, then if we define all the stuff again, we get immediately new and init being called. So, if you inherit from keyword arg metaclass, you get those two things happening as soon as you define the class. And then you create a metaperson, call it just like before. Question?
Sorry, why does init get called on metaperson at definition time for the metaperson class?
Because new is a class method, but But new is a class method of the metaclass. So it takes in the metaclass itself. Metaclass. So that's why new takes in the metaclass. But init is a non-static method. It takes in the instance. And here, we're in the metaclass, so the instance is the class that we're making. Metaperson. So init gets called on Metaperson.
So
New returns Metaperson.
I would expect metaclasses init to be called, not metaperson.
Metaclasses init. This is metaclasses init. This is the metaclasses init being called on the instances. Yeah.
Okay, gotcha.
Yeah, good question. Questions about this? The takeaway here is that by defining new and init and call in the metaclass, we can hook into different parts in the class instantiation, the object instantiation protocol. So let's see an actual example. That was kind of dumb. What if we want to have classes that know about all of their subclasses? That's not something we usually think about doing. We usually think about the superclasses not knowing about their subclasses. So it's kind of weird. But now that we know that classes are objects and we have a way to subclass type, we can change the behavior of classes. And so it turns out doing that is actually not too complicated. We've got a registrar metaclass, inherits from type, and we're going to define a function. And it takes in class. It takes in class because we're in a metaclass right now, and so instances are classes. So the instance is CLS. And we're going to assume that we have this field here, subclasses, and we're going to append that C to it. And now in the init, we're initting a class called CLS, and we're going to make that field. And then the magic happens. After initting the subclasses field, we're going to go up the MRO of the class that we're now creating. The init gets called when this metaclass gets called, which means it gets called whenever a class is defined. So now, upon definition of a class, we're saying go up the MRO of that class, and if that superclass has an add subclass method, and that method is callable, call add subclass on self. So what is init here? Init gets run at class definition time. So if we define a class that uses the registrar metaclass, immediately upon defining it, we're going to search up the MRO and add ourselves to all of our superclasses, so that our superclasses know about us. And so if we use this, here we've got A as a metaclass, A is a class, but its metaclass is registrar. And we look at A's dot subclasses to get the empty list. And that's what we expect, because we just constructed a brand new class here, and it doesn't have any subclasses yet. The interesting thing here is that we're accessing this field on the class itself. Usually we're used to accessing, dot field on objects, instances of classes. But now our class is an instance of the metaclass, and so we have these fields here. But now if we define some subclasses, immediately after defining each one of these classes, this code is getting called. And these classes are adding themselves to each subclasses list. So now if we check it, we can print out C.subclasses, and we get all of the subclasses. We can print out A.subclasses, and you can see it changed from before. Before, we hadn't defined any subclasses yet, so A's subclasses were empty. But now after defining a bunch of classes, effectively calling the constructor of the metaclass, this code has run a bunch of times, and all of these classes have added themselves to their superclasses lists. Does that make sense? Questions about this?
What was the callable for? You're checking that has the subclass?
It's just an extra check. I mean, it's possible that maybe some other custom metaclass would define an add subclass field that isn't callable. Pretty unlikely. It's just an extra check. Yeah.
When is the MRO filled out?
The MRO what?
When is it filled out? Like, this is like when the
Oh,
class created.
good question.
How does that already have the MRO?
Yeah, so and that's a nice thing about the difference between new and init. So it turns out that constructing instances of registrar is creating classes. Init takes in the class after it's been constructed and populates it. New takes in the metaclass and constructs class, and it turns out that it's in new that the MRO is built. So as soon as, here we didn't define a dunder new method, but if we had defined a dunder new method and called super dunder new, then it's at that point that the MRO would have been computed. Yeah, good question. Other questions about this? So here's another use case. Singletons. A singleton is a special kind of object / class where you can only create one instance of that class ever. So some examples are true and false. True and false are instances of the bool class. And if we get the ID of true, this is like the memory address that this object is stored at. So the memory address is some random number. If we get the ID of bool1, we're constructing a new Boolean object here with a truth value of 1. So we expect this thing to be equivalent to true but different because we're constructing a new one. But it turns out that if we get the ID, it's exactly the same. And that's because bool is a singleton class. There can only ever be exactly 2 instances of bool, bool1 and bool0. If we try to construct a new true, it'll just return the true that already exists. So that's a singleton. And now if we want to do singletons, kind of the best practice way to do that is actually with a metaclass. So our singleton metaclass, we're going to define a nit again. And this time, we're going to add a class field called instance. And so, whenever we call this class, we're going to check to see if we've already created an instance. And if we have created an instance, we're just going to return the instance that already exists. Otherwise, then we'll call supercall and actually create an instance and set it to the instance variable. So now what happens? We create a person class, the metaclass is singleton. We define some methods, doesn't really matter. Now if we create a person, Leah's my sister, by the way. That's why those are the 2 names I use to go to is Max and Leah, because shout out to Leah. So if we construct a new person here and call .talk, what do we expect? Well, what code gets run? We're calling the class. We're calling the class, and this is an instance of that. And so we're actually in this call method. So the very first thing we do is we check if capital P person .dunder or .underscore instance is not none. And it's not none. Or sorry, it is none. It is none, yeah. And so we skip this if statement, we get down here, we call a supercall, we set it to the instance field, and we return. So we get what we expect here. This actually creates a person, Leah, and we call it talking get Leah. But now if we create a person, Max, now what happens? Well, we're calling this variable again. So we're back in this call method, but now capital P person .underscore instance is not none. We've just created a person, and we set them to the field. So now we return the instance that already exists, which was Leah. So if you try to create any other person now, it'll always just return Leah. Leah is the only person. It probably doesn't make sense for person to be a singleton class, but I just feel like person is just the most easy to understand class to use as an example. Questions about this? Okay, one cool thing here is that metaclasses are inherited. So now if we create a subclass of person, its metaclass is also singleton. So now if we create a student called Max, what do we expect here? There's a couple things that we might expect. First of all, it could work. We could get MTP4BE. Other thing that could happen is that maybe calling this actually returns Leah again, because Leah is the only person that ever exists. But if this returns Leah, Leah doesn't have a report method. Leah is an instance of person, so it's possible this could error.
So I'm thinking that CLS is different in the meta class.
Exactly. We're in a different class now, and so we're actually talking about a different instance of singleton. And so we have a different underscore instance variable, and so we actually do construct a new student here. So this works, but now if we create another student, it does not work. So this is kind of the end of the first unit, so to speak. So far we've been doing everything object-oriented. Every step we've taken so far has been in realizing that something that isn't obviously an object actually is an object. And this culminated with metaclasses, where we could actually turn class creation, class definition, into an object-oriented process. And all of this has been pretty meta. But it's just one vein of metaprogramming. So starting next week, we're going to move on to something called reflection. And reflection is really like it's like the tool that makes all of this stuff really useful. We've done a bunch of meta stuff, taking in functions as objects, classes as objects, but with reflection, we can actually look at those things, change them, manipulate them. That's when we're going to start getting into the code modifying code part. So look forward to that. It's going to be a lot of fun. Yeah, that's all I got. So hope that blew your mind.